In this exercise, we will investigate the behavior of an LC parallel and a resistor in series in an AC configuration. So let's go ahead and start with LT Spice to simulate our circuit. Yes, I think that will be good enough of a surface. Let's go ahead and put our lines. So I will start from here, approximately right here, right here. That should do it right there. Then I will have my inductor between these 2 points. There. Okay. Next, I want my AC source. Okay, we're going to use the same one we used for the previous examples. I'm going to go to Component. I will pick this power supply. Let's set its characteristics. So I will go to Advanced. This will be a sine wave generator with a DC offset of 0, 10 volt amplitude. For now, we could put 60 hertz, but that's not gonna be as important since I am going to test this circuit over a range of frequencies, okay? And again, 10 volt peak, 0 degree phase shift. So we are starting at 0, 0. Fantastic. Let's go ahead and put our inductor here and capacitor right here. And do not forget the resistor. Let's start with that. Let's put a resistor first. And what I'm going to do with the circuit is I'm going to set a range of frequencies, and then I'm going to vary the resistor and see what effect does that have on the circuit. Okay. So I am going to go for component, and I'm going to put a resistor here. Command R to rotate it, put it here, hit escape. For now, let's just put a 10 ohm. I will be varying this, and you will see. You will soon see why I will be changing this value. Okay, we're going to get some very interesting results, especially for tuning circuits. So let's go ahead and do component here. That will be the inductor, and we're going to choose my famous 2 millihenry. And you can guess my capacitor will be a 5 microfarad. I'm just going to stick with these values right now. Okay, because I can predict quickly what my resonant frequency will be. We could do the math for it as well. But I will leave that for another video. For now, I just want to see the frequency response. And here they are. So this one will be a 5 microfarad. There you go. Let's put a ground over here. This will be our point of reference. You could put it right here if you want. And hit this. Let's get a line. From here to here, hit escape. Fantastic. Everything is connected. Now let's set our frequency range in which we're going to simulate and get a frequency response for the output of this circuit. That is what we're going to be observing. So I'm going to go to Spice Directive. This time, I'm going to go to AC Analysis. We've seen the transient will work, but it will take forever to get all your points together to figure out exactly what the frequency response is. It's much better to do it here. I'm going to go ahead and put 200 points per octave. That's just for drawing it. And I will start at 100 hertz. I can even go down to 10, but that's fine, 100 hertz. And then about maybe 10K or 5K. Let's go ahead and do a 10K for now. And I'm going to do this and put this over here. We can always change this range from 100 hertz to 10K. Might be too much. We'll see. Okay. Now let's run this simulation. As you can see, I have a frequency range starting at 100 hertz to 10 kilohertz. I did not pick on the system yet what will be the frequency response of the system. All you have to do is probe the output. Well, let's do that right here. You can probe anywhere on this line right here. And there you have it. Aha! You could see that it's peaking somewhere and then it drops back. And there's a phase angle shift here. Let me go further than 10 kilohertz and go for, I would easily go to 20 kilohertz right here. So you can go over here, change that to 20 kilohertz, and we can observe again the behavior of this. And let me just make it a little bigger so you can actually see this. And if it's still skewed, I can add more. Okay, it's a bit skewed. I want to balance it out in terms of the visual. So I've got 20 kilohertz there. This is a logarithmic view here, apparently. I have 100 hertz here. That's fine. I'm just looking at the whole range. I think this is okay. I'll leave it here and observe that you're peaking at a certain frequency right here somewhere. And notice it's 1.5. Okay, it is almost the same frequency that we did with the series circuit, right? For the resonance. That is resonance right here when you're maxing out over here in terms of the impedance. Okay? And after that, it's a matter of what is your circuit doing? Is it more capacitive on this end or is it more inductive on this end? How do we know that? Well, this curve right here shows you the phase shift. And if I put a grid here, we could see that at 0, right here is your max. And it's 1.59 kilohertz. Fantastic. And notice where my mouse is. This is at 0 degrees. That is resonance at that level where it's neither capacitive or inductive. At 0 degrees means the circuit is resistive, which means this whole impedance here, right? They both, each one, remember they're 180 degrees from each other. They cancel each other out. And I'm left with 10 ohm as being my resistive circuit for the whole, as far as the impedance is concerned. However, I want you to observe what happens if I lower or increase this value. Now, that's going to be important in case you want to create a tuner of some form, right? Let's lower the resistance and see what happens, which means now what's going to happen is most likely this curve will flatten, okay, a little bit. So let's go ahead and put 1 ohm. Now, I can't put really 0 here, but I'm just going to put 1 ohm. Let's run this again. And, okay, to run it, you're just going to have to do this. Let me make it a little bigger. And now we're going to select the output again, which is this one right here. There you have it. Now let's look. Voila. You have a nice, kind of a larger bandwidth in which the impedance right here is pretty much the same for a certain range from here to here. Okay? Then it drops off. Great. So can we narrow this? Can we really narrow this? Sure. Now remember with 10 what we did. So let's go ahead and do a factor of another 10. So 100 this time. And let's look at our graph and see what happens. Okay, so I'm going to run this again. Make this a little bigger. Let's see what it would look like as I sample the output. And there you have it. Okay, so we have a dramatic shift of the angle right here at 0. It's specifically when you reach the peak. That's the resonant frequency for this circuit. Okay, all right, well, let's increase it even more. Let's make it 1,000. 1 kilo ohm. Right, let's run this again. Let's see how that curve or that bell curve reshapes itself. So I'm going to just select the output here. And there you have it. Okay, so again, the angle shifts. So let me just go ahead and put some grid. The angle shifts right. That means it reaches 0 right at this maximum. And this maximum here happens to be 1.6 or 1.59 kilohertz. Okay? Good. So this is a typical circuit used for tuning. Right? So if you really want to tune to a carrier frequency, this is a configuration that you might want to consider. And then you could narrow the band with the value here. You could select which frequency you want to tune in. Well, let's shift this thing a little bit to the right or the left. Let's say we want to shift it and put here, you had a 20. Let's go by a factor of 10. Let's see what a 20 millihenry will do. Now remember where our frequency was. It was at 1.59 kilohertz as far as the resonant frequency, right? So let's go ahead and do this again. And you need to run it. Let's see what a change in the induction or the inductor will do. And let's do this here. And notice now we have a shift. Okay, and let's go ahead and put the grid so you can see for yourself that we have shifted towards the left, which means it is more inductive right here. And notice that your frequency of resonance is 500 hertz, right? So now let's go back the other way. Let's see what happens when you change the capacitor. Okay, this is exactly how you tune your radio by turning that knob. What happens is you're moving the selection, all right? So let's keep this one steady. Let's keep it back to 2, okay? And change this one to by a factor of 50. So 50 microfarad. Let's see what happens. Okay, let's see if this will shift to the other side. Okay, we'll go to the circuit again. Click on it here. And let's see what frequencies we're getting here. And now remember, so let me just go ahead and put a grid. And we're at 500. So this is the balance between them. Now let's start from this point adding more capacitance. And let's go ahead to 500 microfarad. And then we're going to go the other way. So you could play. So let's go ahead and play with this. So the capacitor is typically what we would find in a radio that you can modify. When you're turning that knob, let's see what happens here. Voila, it's shifting right here. Okay? Right, because as we're increasing C, X of C is decreasing. So it's becoming more and more inductive. Okay? Now, let's lower the capacitance and see if we could shift this over to this side. Okay, so as you can see here, we're about 158 hertz. So if that's what you're tuning, that will be the station you'll be tuning to. Okay, so let's change this now to 0.5. And see what effect that has on our selecting a carrier frequency, right? Okay, so yeah, you have a whole spectrum of frequencies to select from if you have a tuner, right? So let's click here, and notice now we would have a shift to this side. And where is that at? And notice now we're at 5 kilohertz, right? So we've shifted dramatically towards a more capacitive circuit here, right? Okay. What if you did even more? And let's say we went down to 0.05. Now, those are dramatic changes. I'm doing these by factors of 10. I may have to increase the range in which I measure my spectrum here. So again, be flexible. Find out if indeed that's what you want to do to view where are you tuning. So if I click here, let's see if it's out right here. As you can see, I'm reaching the end here. All right, well, to view this, all you have to do is increase, right, the range or the bandwidth in which you're observing. Remember here, we had 20K. We could change that to 200K or 50K. All right, so I'm going to change it to 50 kilohertz. Hit enter. And let's see what we get. So I'm going to run this. Okay. So I urge you to experiment to feel comfortable with these ranges and get a good idea what you're looking at. So right here, and voila. Okay, so as you can see, I'm starting to get more, to see more of the behavior here. Let's go ahead and increase this into even more, so we could see the whole spectrum as much as we can. So let's go to 150K. So it's 150 kilohertz. Okay, we close this, run it. And evaluate the output. There you go. Right, so again, below a certain point, depending on what you're doing, you're interested in this. This is the significant value. This is just showing you the trend as to what's going on with the total impedance. Okay, so we have enough information at this stage. We could see the angle shifting, okay? And we could see that our peak, or where resident frequency is for this particular configuration. Can I narrow it down even more? Yes. All right, well, let's put another 0 here. And let's run this again with this configuration. And let's pick on the output. And there you have it. Okay, I hope this has been very informative in terms of how to use an LC in parallel and eventually to use it for tuning to carriers so you can capture radio stations, for example, in AM or FM.